All right, so with that being said, I hit the recorder, so hopefully it's recording. What we want to do is I'm going to share my screen, and we'll go through, wrong share. So I want to share my screen. Okay, so got these two pages up. So I've got quiz number 2 we're going to look at, and yeah, so we're doing these by dimensional analysis, and the main thing is I would say my biggest tip for a lot of people is actually don't read the problem. A lot of people will read the problem and try and keep track of all the numbers in their head, and it'll get really confusing, and they'll try and use every number and all sorts of things. But really what you want to aim to do is just try to look what your unit is that you want to finish with, and then from there, just try and cancel out all the unnecessary ones. So with that being said, why don't I just try and copy these over? Make the font a bit bigger. Okay, so these first few, I mean, I would say they, for the most part, kind of get a little bit more difficult as you go on in this quiz. But all right, so the main strategy, I always start looking for what they're asking for. So that's at the end. I'm looking for tablets, and then I write down whatever that is that they're looking for, and I try to find that unit somewhere in the problem. So I see that right here, 325 milligram tablets. That means for each tablet, there's 350 milligrams of medication. So this thing that I'm starting with, I want to put on top, and I know that that one tablet is 325 milligrams. And so that's what I want to do now, is I want to do what I can to cancel this milligrams, because I know the final unit should only contain tablets. So that milligram is kind of unnecessary. So I would look in the problem for anywhere where I would see milligrams. I don't see milligrams, but I do see grams. So I would kind of call this like the medication family, if you will. So you have just 2 conversion factors here, because your medications are going to be measured in either grams, milligrams, or micrograms. So we know that 1,000 milligrams equals 1 gram, and 1,000 micrograms equals 1 milligram. So if you want to think about it in terms of big, small, smallest, we have grams as the biggest, milligrams in the middle, and micrograms as the smallest. So anyway, so what I want to do now is I want to use this 1,000 microgram, or I want to use the 1,000 milligrams to 1 gram, so that I can then use this ordered amount of 0.65 grams. So I'm going to multiply by 1,000 milligrams over 1 gram. Notice units will only cancel if they are in opposite parts of the fraction, meaning the milligrams cancel because the 1,000 milligrams is on top and the 325 milligrams is on the bottom. If they were both on top, they would not cancel. Your units would not cancel. So we know the milligrams is gone. Now I need to cancel grams, and I do that with the ordered amount, the 0.65 grams. And anytime you have an ordered amount, it gets a placeholder of 1. So there's 2 times you're going to get placeholders, either ordered amounts or patient weights. So this is an ordered amount, so it gets just a 1 on the bottom, which doesn't have a unit. You could think of it as meaning the 1 ordered dose, but it doesn't have a unit to cancel. So then grams is gone, and then we just multiply on top and multiply on bottom. So we end up with 650 over 325, or our final answer of 2 tablets. So that's it for number 1. Pretty easy problem, but Let's go ahead and look at number 2. Again, like I said, they're a bit easier at the beginning. Okay, so for number 2, again, don't read the problem, just go straight to the end. It's asking how many milliliters should the nurse administer, so that's where we're going to start, milliliters, and then I'm going to look for milliliters in the problem, and I see it right here. And I don't see it anywhere else. So I know that 1 milliliter corresponds to 10 micrograms of the medication. And then that's all I have to do is cancel micrograms, and that's the ordered dose right here, 7 micrograms. And I'm all done. And I just get my answer of 7 over 10, which comes out to 0.7 in the calculator, and that's milliliters. So only a one-step problem there, nothing too difficult. They don't really get too interesting until we get to number 4, I don't think. And feel free, if you have a question or something, jump right in and let me know, and we can stop. But for the first few, it may be not too difficult if you're used to this method, the dimensional analysis method. Again, sometimes other textbooks will show different ways, but I kind of find this the most straightforward and similar to how you do things in, say, chemistry. Number 3, again, if you go to the end, we see that we're looking for milliliters. So we've got milliliters equals. The only place we see milliliters is right here. So we have the concentration, 40 milligrams per milliliter or per 1 milliliter. So I want to put the milliliters on top, again, because milliliters is what I'm starting with, so that needs to be on top. Kind of think of the milliliters. So on the left side of the equals is your roadmap. Once that's all you have left, you know you're finished with the problem. This is per 40 milligrams. And then again, I'm looking for milligrams. I don't see milligrams, but I have something in that medication family, grams. So I'm going to use the same conversion factor as before, 1,000 milligrams, put that on top so it cancels with the milligrams that's on bottom per 1 gram. So my milligrams drop out. And then I can use the ordered amount, the 0.168 grams, which is the dose, over 1. And then I multiply across. And then I want to do that division. It says round to the nearest tenth, so that's 1 decimal place. So it actually just comes out exactly to 1 decimal place, so it's 4.2 milliliters. And that's it for number 3. I think for number 4, we get something a little more interesting, at least if memory serves. So yeah, this is a little more interesting because, well, we know we have a rate, units per hour, that we're trying to finish with. I always just like to start with whatever's on top of the rate, so I would be looking for units. But you see there's a bit of an issue now because units appears twice in this problem. I've got 0.2 units per kilogram per hour, and I also have 125 units and 250 milliliters. So can anyone tell me which of those 2 numbers they would use? Or you can just type it in chat, I guess. But what would your inclination be? 0.2 or 125? So the 0.2, good, 0.2 is correct. The reason it's correct, I would say this 0.2 has both units and hours, so it's matching 2 things that we already have here. A lot of times when you'll have the thing that you're looking for appearing twice, you're going to have extra information. So we're actually never going to use that 125 units and 250 milliliters in this problem. So if you're not sure about when you have extra information, that's going to be one of the times when it happens. So I'm going to write this 0.2, and then I'm going to write the units on top, and then the other two both belong on the bottom. So I'm going to write my kilograms per hour on the bottom, and you want to think of both of those as being on the bottom of the fraction. So then what do we want to do? Well, hours is in the right place, so we just want to get rid of kilograms. And then we don't see kilograms in the problem, but we do have another patient weight that's 156 pounds. So I would call this the patient weight conversion. This is when it comes up typically. And that is just a conversion used from pounds to kilograms. So we know that 2.2 pounds is equal to 1 kilogram. So we're going to want to use that. We know kilograms has to go on the bottom of the fraction. So I'm going to put my 1 kilogram on the bottom, and I'm going to put my 2.2 pounds on top. And now this is something that will often throw people for a bit of a loop. Wait, did I? No, we were canceling it. Sorry. I messed that up. We want to cancel kilograms, so the kilograms needs to go on top. So I have 1 kilogram on top and 2.2 pounds below, because kilograms needs to be canceled. We're not trying to keep it. Excuse me. And then we have the patient weight, 156 pounds. And remember, patient weights are the other things that get placeholders. So that 1 on the bottom has no unit associated with it. You can think of it as being like 1 patient. So then the pounds are canceled, and the only units left are the units and the hours. So we just multiply across. So we get 31.2 over 2.2. And then want this rounded to the nearest whole number. So that comes out to 14 if you round to the nearest whole number, 14 units per hour. Let's go ahead and continue. Let me grab a highlight. It's the touchpad. For number 5, where we have, again, look at the end. Don't get stuck reading the problem. That'll just serve to confuse you typically. I mean, it's okay to reread things, but really we want to follow the units. And then once you've got it set up, you can go back and read it if you think anything is problematic looking. But I would say follow the units always to start. Okay, so milliliters, we see 5,000 units per 1 milliliter. So I'm going to start there. No other milliliters in the problem. I want the mLs on top. So 1 ml is over 5,000 units. And I want to try and cancel units, and this is just 55 units per kilogram. And then we've got our patient weight, so 93 kilograms, and the patient weight gets a placeholder of 1 at the bottom. So units dropped out, kilograms dropped out, and I'm just left with my milliliters. So I end up with 5,115 over 5,000. They say the nearest whole number, and that just comes out to 1. So this is 1 milliliter. Number 6. Okay, so I think 6 is one of the longer problems. I think on this quiz, I would consider 6 and 9 the most difficult, at least in terms of number of steps. That's something else in the chat, so check that. Can slow down a bit for 6. Sure. I can actually let you guys have some time to try it on your own if you want. So why don't I give you maybe 2 minutes to try and write this one down. Again, that's all I'll say to start it out is we are looking for milliliters per hour. So you want to do milliliters per hour. So see if you can go ahead and follow the strategy that we've had so far and go through the problem.
I had a question.
Sure, go ahead.
So you never cancel out the number. It's just the unit that's with it, like the gram, the milligram, the milliliter.
Yeah, right. Everything else we do in the calculator, but we're
Okay.
only canceling the actual unit.
Okay, because I guess that's where I was making my big. I don't know why I was. I guess previously people were showing me like when they mark it out, they're marking out like the whole number. So I was thinking like they were marking out like 3 milligram.
You can, but that's bringing arithmetic into the game. So
Okay.
if you're worried about making mistakes using mental math and simplifying fractions, you just want to leave that alone and use your calculator.
Okay, so you're just timesing it straight across and then timesing it straight across the bottom.
I'm multiplying everything on top, getting that number. I'm multiplying everything on the bottom, getting that number, and then I'm doing one division step at the end, and all that in the calculator.
That sounds so much easier than what they were trying to teach me before because this, yeah. Okay, yeah. That makes sense.
So yeah, if that's not, if you think you're going to make a mistake there, don't even leave the chance.
Okay.
Okay, so let's walk through this one and see if you're able to get it okay. So I would start here where I see milliliters, 2 grams in 1,000 milliliters. So I have my 1,000 milliliters over my 2 grams. So then I'm looking for either grams, milligrams, or micrograms. And I see that here, 3 milligrams per minute. So that means I have to use a conversion factor. So I want to cancel my grams. So 1 gram has to go on top and 1,000 milligrams has to go on bottom. So the grams are canceled. And then I can use my 3 milligrams per minute. Okay, so now milligrams are gone. So let's take stock of what's left. We have milliliters per minute, and I just want to change minutes to hours. So this wasn't quite as bad as I thought. So to change minutes to hours, we know there are 60 minutes in 1 hour. So then your minutes are gone. The only units left over are your milliliters and your hours. So then again, just multiply across. Typically, too, the more steps you have, the bigger the numbers are going to be. So you really want to pay attention to counting zeros if you're just doing everything on your calculator. So, right, this is an 18 followed by 4 zeros. So if it's a big problem like this, you really want to double check that just to make sure you didn't miscount or press one too many zeros on your calculator. So we end up with 90 milliliters per hour as our answer. So hopefully some of you were able to get that. It didn't turn out to be as difficult as I thought it was going to be. Let's look at 7. Okay, so for this one, we've got a drop rate. So we're looking for drops per minute. So I'm stopping there, drops per minute. So then I'm going to look for GTT somewhere in the problem. I just want to look for drops. I see that this one place, 20 drops per milliliter. So I've got 20 GTT over 1 ml. Or you can use GTTS. I don't know if it matters. Let's just stick with GTT to be consistent. So I get rid of this S. All right, so now we need to cancel milliliters because that's on the bottom and it's not what we want to finish with. We want to finish with drops per minute. So that means we want to use this 85 ml per hour. So I've got my 85 ml on top, so it cancels with the ml on bottom and my 1 hour. So these mLs are gone. And then drops per hour is not so far away. I just need to change my hours to minutes. So 1 hour goes on top, so the hours cancel. 60 minutes goes on bottom, which matches where it should be according to the drops per minute that we want to finish with. And then again, we just multiply. So we've got 1700 over 60. And nearest whole number, it comes out to 28.3 repeating, so that would just round to 28 drops per minute. So number 8. Okay, so we're looking for milligrams per hour. So milligrams over hours. Okay, so again, I want to start with what's on top, milligrams. So I'm looking for grams, milligrams, or micrograms in the problem. The only one I see is this 4 grams. So I'm going to start with my conversion factor so I know milligrams ends up in the right place. And I know there are 1,000 milligrams for every 1 gram. Again, this conversion factor can be used either way, either as 1,000 over 1 or 1 over 1,000. It just depends which place your units need to be in. Milligrams is on top, so that's why the 1,000 milligrams needs to be on top, which means the 4 grams over 250 milliliters, the 4 grams will go on top to cancel with the 1 gram on the bottom over 250 milliliters. So now grams is gone. And I want to look for milliliters in the problem. And I find that right here, 120 milliliters per hour. So I have 120 ml over 1 hour. And I'm already finished. The mLs are gone, and I can just multiply across. So I end up with 48 followed by 4 zeros. And I'm dividing that by 250. And that comes out to 1920 milligrams per hour. Anyone have any questions there?
No.
Okay. Let's do number 9. I'll give you a chance to work this one. This is typically the on all my sample quizzes, the most difficult of the problems. I think really none of them are actually difficult. It's just how many steps they take. So again, I'll give you a few minutes to work on this one before I get you started. I'll just write down what we're trying to finish with. We're trying to finish with this micrograms per kilogram per minute. And whenever you have a ratio with like a double ratio like this, I always want you to write it with the first one on top and the other two on bottom. So think of micrograms on top and kilograms per minute on the bottom. So go ahead and give that one a try. Okay, so let's see how I did. Again, I want to start with the thing on top, micrograms. So I'm looking for either milligrams or micrograms or grams. So I see 15 milligrams here. So I want to start by using my microgram to milligram conversion. Remember, micrograms is the smallest, so that means there are 1,000 micrograms per 1 milligram. And then I can use the number from the problem, the 15 milligrams over the 1 milliliter, to ensure that my milligrams are canceled. Now I'm just focused on canceling milliliters. So I see milliliters right here, 50 milliliters per hour. So I do 50 mLs over 1 hour. So now those are gone. So I'm currently sitting with units of micrograms per hour. I know I want minutes on the bottom, so I can change my hours to minutes. So I can do 1 hour over 60 minutes. Now I've got minutes in the right place. But there's still one thing left to do. There's a kilogram on the bottom that we don't have yet. So I know since it's kilograms, it's going to be a patient weight of some kind. This is usually where students end up getting stuck, this step or the next one. So I do have a patient weight in 208 pounds. So in order to use that, I'm going to want to use my pounds to kilograms conversion factor. And notice kilograms needs to go on the bottom. So my conversion factor is 2.2 pounds over my 1 kilogram. So now kilograms is in the right place, and that's all I have to do is cancel pounds. So in order to cancel pounds, notice the actual weight needs to go on the bottom of the fraction. A lot of times when we have these patient weights, they end up with the weight on top and the placeholder at the bottom. But in this problem, it's exactly the opposite. Just because it's less common doesn't mean it can't happen. And notice if pounds is on top, the only way to cancel that pounds is by having a pounds on the bottom. So the 208 lbs goes on the bottom and the 1 goes on top. And then again, you just multiply across. Again, this one has quite a few steps, so you want to make sure you're counting your zeros properly. So we end up with 165 and then 4 zeros. And then on bottom, we end up with 12,480. So we end up with 132 nearest tenth. So this rounds to 0.2, and that's micrograms per kilogram per minute. So how did that problem work? Was anyone able to get it, or did they get tricked on the last step there?
I was tricked through the whole thing.
Oh yeah, what would cause some? What would confuse you?
Not knowing where to start with this one.
Well, you always start with whatever's on top, right?
Okay.
So if you start with micrograms, there's only 3 things you're looking for. You're looking for grams or milligrams or micrograms. So then, right, this is the first place I looked, and it's milligrams. So I see milligrams and micrograms, so I know I need to use that conversion factor.
Okay.
Right? So I started with the conversion factor, then I just started with canceling things.
Okay.
So it really doesn't work any different than any of the other problems.
So it didn't matter which one I started with. I could have started with the 50 milliliters per hour or the 15 milligrams per milliliter, correct?
No. I'm telling you to start with things in a very particular order.
Okay.
To try and avoid confusion. I mean, you could start in different orders, but I'm kind of giving you a step-by-step list. And I'm saying when you write down your roadmap, the units that you're trying to finish with, always start with the 1 on top.
Okay.
And then you want to use the conversion factor so that you know micrograms ends up on top, which is where it needs to finish.
Oh, okay. That makes sense.
Right. If you don't end up with micrograms on top and kilograms and minutes on the bottom, you did something wrong. You don't even need to do the math in your calculator because, right, micrograms finishes on top, kilograms needs to finish on bottom, which it did right here, and minutes needs to finish on bottom. So if those 3 things don't happen, you did something wrong. Everything else should be crossed off. Milligrams are crossed, milliliters are crossed, hours are crossed, pounds are crossed. So that's the advice I would give in terms of making sure that things end up where they are. If that doesn't happen, you did something wrong and you need to start over. Number 10 is a safe dose problem. It's written a little odd on this one, but it's from an old quiz, so. Have a look. Again, a safe dose is really just giving you a range of medication that's that could be given to a patient, usually a minimum and a maximum. Sometimes they'll just give you a maximum to make sure you're not doing more than that. So there's a couple ways I tackle this problem, but it says what's the maximum safe dose that they should administer in a single dose. So that's going to be whatever they're medicating them in, either grams or milligrams or micrograms. It doesn't tell you. Typically, it's usually milligrams. So you want to do milligrams equals on this problem. That's what we're looking for. And then if you want to do it all on one problem, you kind of can, because the thing is, it's giving you not the amount per dose. This maximum safe dose is the amount per day, right? And then they're telling you each day you receive 3 divided doses. So you could think of this as 9 milligrams That's a bad 9. You could think of it as 9 milligrams per kilogram per day. And then you could think of 1 day as having 3 doses. Usually we don't write down doses in the final answer, but it's just to show you that basically we need to divide this by 3. And then to cancel the kilograms, we would just use the patient weight. So we have the 50.3 kilograms over the patient weight. So we end up really with just one. So you would end up with 9 times 50.3. So 452.7 divided by 3, which would come out to 151 milligrams, rounding to the nearest whole number. And that would be your answer. Some people would choose to do it in the other order. They might say, okay, well, I need to do 9 milligrams per kilogram and then divide that by 3 to figure out my milligrams per dose. So I would have 3 milligrams per kilogram per single dose, and then go from there and say, okay, well, milligrams is 3 milligrams per kilogram, and then multiply by the 50.3. It's essentially the same exact thing, though. It's just written a little bit different. I prefer to write it all in one line, but if you want to do it kind of in 2 separate steps, I understand. That's just because this problem's a bit odd because they're giving you the dose in terms of entire daily medication rather than per dose medication, when that's what they want. They want the maximum single safe dose. So I don't know. For me, this problem was, just worded a bit funny, which is the only reason it caused confusion. Okay, so would anyone like me to go over any of these problems, or do they have problems of their own that they have questions about? I'm happy to do any of those. Other than that, in the folder that you downloaded, you should have, 2 more sample quizzes, quiz 1 and quiz 2, and all of them have solutions. So for instance, the quiz we just went over, I've typed out all the solutions, and they're also in the same exact order that I would do them, right? So we see 151 there, 132.2. They're all in pretty much the same order that I do them. So the way I've told you today, you're going to see them there too. But again, when you're practicing these things, you don't want to, you really don't want to just read solutions. Anytime you're reading solutions, you kind of just feel like a genius and you're like, oh, well, I understand that. So certainly I'll be able to replicate that when I get a question. You don't really know that for certainty. What you want to do is you want to work off the blank quiz, try to write down the answers yourself, and then once you're done, then compare that to the solutions. And then you can see if you really do understand the material, because you were doing it without kind of having the help of the notes sitting there to guide you along. So that would be my recommendation for practicing. Okay, so any other questions, comments, concerns? Okay, well then I will stop sharing. Forget how to do that. Oh, it's right here. And I hope everyone has a nice day. So if you have any other questions, please feel free to ask them. Otherwise, I think we'll finish here. All right, sure thing.